Hi, Assalamualaikum. Today we want to present our presentation about two experiments, which is linear motion and friction forces. I will start with my part first, which is linear motion. Okay, so introduction to the experiment is linear motion is the movement of an object in a straight line. It is one of the simplest type of motion where an object moves in a specific direction without changing its orientation. Key concepts in linear motion include displacement, the straight line distance between an object starting and final position considering direction, while the velocity is the rate at which an object moves in a specific direction. Acceleration is the rate at which an object's speed changes over time. So linear motion can be described using equations that relate displacement, velocity, acceleration, and time. This equation help us predict an object's future position and speed. Example of linear motion include a car driving on a road or an elevator moving out a building. Okay, so now we move to the apparatus. The apparatus needed in this experiment is air thread rail blower, pressure tube, glider, flap photo gates, mesh hanger, string, and pulley. Okay, so the procedure is as 1. Assemble the air thread system as shown in the diagram on the next slide. Okay. 2. Turn on the pump to allow air through the thread to the thread. Balance the thread by adjusting the screw so the glider stays stationary when released. 3. Attach a hole and flag to the glider. 4. Measure and record the masses of the hanger, glider, and the flag length. 5. Connect one end of the string to the hanger and the others to the glider. Place 20 grams on the hanger and 80 grams on the glider. Pass the string over the pulley. Position the glider before the photo gate. Release it and record the time from the photo gate. Catch the glider before the hanger hits the floor. 8. Repeat this step 2 or more times to calculate the average time. 9. Transfer 20 grams from the glider to the hanger and repeat the procedure. 10. Perform 3 more trials, transferring 20 grams from the glider to the hanger each time. So this is a complete setup for the experiment. So this is the result of the experiment that we got.
And also, I have provided you guys a graph for experiment 4. The first analysis is, what does the graph tell us? The relationship between the weight of the hanger and selected mass and also acceleration. The weight of the mass is directly proportional to the acceleration. It is because the higher the mass of the hanger and the selected mass, the higher the acceleration. Based on the graph, we note that the second law of motion tells us that force F is directly proportional to acceleration A. When the force increases, the acceleration also becomes increased. This indicates that if mass is constant, then force equals mass multiplied by acceleration. F equals to ma. The second analysis is determine the gradient m of the graph. Here I use the formula y2 minus y1 divided by x2 minus x1. The first coordinate is 40.61 and 0.884, and the second coordinate is 10.197 and 0.687. When you insert the coordinate in the formula, we get 0.054 kilogram. The fourth analysis is calculate the uncertainties of gradient m. So the first one is we need to find the gradient m of the minimum point. So 0.7859 minus 0.0965 divided by 12.79. So and the answer is 0.0539 kilogram. The second one is we need to find the gradient of maximum point. So the calculation is 0.7859 minus 0 divided by 12.79 minus 1.790, and the answer is 0.071 kilogram. And the third one is we need to minus the maximum point and the minimum point and divide by 2, and the answer is 8.75 multiplies with 10 to the power of negative 3 kilogram. And the last analysis is briefly explain the relationship between the gradient m from the graph and the total mass. The gradient in the graphs is directly proportional to the mass in the system. It shows you that overall mass that produces the acceleration when the force is applied. For discussion 1 is calculate the percentage difference between the gradient m and mt. What is the percent error in this experiment value? So the way to find the percentage difference is 10.054 minus 0.19951 divided by 0.1995 multiply with 100, and the answer for percentage difference is 72.93%. And then we need to find the percentage error. So 0.00875 divided by 0.1995 multiply with 100, and the answer is 4.38%.
Alright, the second question is discuss the factors that have contributed to the errors in the experiment. Some factors that contribute to the error in the experiment are measurement uncertainty, friction, and air resistance. The instruments used, such as rulers or sensors, may not have perfect precision, and human error in reading or timing can become inaccuracies. Friction between the glider and the track can reduce the actual acceleration, affecting the force measure, and air resistance can also slow the glider down slightly, leading to discrepancies in the expected value. Third, explain how to overcome the factors mentioned in question 2. Alright, we can improve measurement precision by using more accurate instruments, calibrating them properly, and double-checking readings to reduce human error. Friction can be reduced by ensuring the track is smooth and by using low resistance materials, like lubricating the track or ensuring the glider moves freely. To tackle air resistance, you can minimize the speed of the glider or experiment in a controlled environment where air currents are less of an issue. Making this adjustment helps reduce the factors contributing to error and improve the accuracy of the experiment. Alright, for the conclusion for this experiment is the linear motion experiment demonstrated how an object moves in a straight line, and we were able to observe the relationship between distance, time, and velocities. The measure factors confirm that linear can be described using basic equations. The experiment helped us understand the concept of speed, velocity, acceleration, and velocity, and how they relate to each other in motion. Overall, it was shown that linear motion is simple to analyze and can be easily measured and predicted by using simple methods.